Hi people, notes 3.4 are on Vertex Form. And Vertex Form is based on everything that we've done here with our transformations of parabolas or quadratic relations. There's a little bit of background knowledge that I'm assuming that you have since we did this together. If you're confused about anything, just write it down on the side and let me know, okay? So just a reminder that Vertex Form is going to look like this. So these are all the different transformations that we have put together. The A value, just a reminder, the A value tells us whether it's stretched or compressed, whether it looks taller or shorter, but it also tells us if we have a reflection over the x-axis. So the direction of the opening will come from the A value. So the A value, if it is positive, means that it opens up. And if it is negative, it means that it opens down. And a way to remember it is if you're positive, you might be smiling. If you're negative, you might be frowning. Just a general way to remember it. I know that's not always true, but just a general way to remember it. Now, the vertex, I'm going to skip over to the vertex. Just a reminder, this tells us that we are shifting right or left. And that's the h value. The k value tells us if we're shifting up or down. And since our vertex for x squared, y equals x squared, is always at 0, 0, our vertex in the transformed relation will always be at hk. Because h just is the x value, it moved right or left. The k value is the y value, it moved up or down. And then lastly is, and this is really important, is the step pattern. So normally the step pattern is usually 1, 3, 5, 7. But when we start to introduce our A value, this A value tells us if our graph is getting taller or shorter. So if our graph gets taller, our step pattern gets larger. If our graph gets shorter, our step pattern gets smaller. So it's always a multiple of whatever A is. So our step pattern is 1A, 3A, 5A, 7A, so on and so forth. So let's apply all of this information into these examples here. So in our first example, we are told that this is our equation right here. Just a quick reminder, this means that A is 3, H is 5, and K is 9. Because the A value is positive, it means that our graph is opening up. Because the H value is 5 and the K value is 9, it means our vertex is at 5, 9. Remember, the axis of symmetry will always occur at whatever the x value is for the vertex, and the optimal value will always occur at whatever the y value is for the vertex. So the axis of symmetry will always occur at x equals h, and the optimal value will always occur at y equals k. Okay? Now, for our step pattern here, we are told to find the step pattern, we just have to do 1A, 3A, 5A, 7A. And because A is 3, it would be 1 times 3. I'll just do this on the side here. And then it would be 3 times 3, and then it would be 5 times 3, and then 7 times 3, so on and so forth. So that means that our step pattern would be 3. 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. 7 times 3 is 21, so on and so forth. All right, in our next example, we can see here that A is negative 1/2. H is negative 4. Remember, it's always the opposite sign. And K is negative 7. For K, it's always the same sign. And because the A value is negative, that means that our parabola is going to open down. Our vertex is always HK. So negative 4, negative 7, which means that our axis of symmetry is x equals negative 4, and our optimal value is y equals negative 7. Really quickly, for this one right here, we know that this is a minimum because our parabola opens up, and we know that this one right here is a maximum because our parabola opens down. Okay, and then for our step pattern here, remember it's 1A, 3A, 5A, so it's 1 times negative 1/2, 3 times negative 1/2, 5 times negative 1/2. And just a reminder, I know we still need to do some more practice with fractions. This is technically 1/1, 3/1, 5/1. So just multiply across, we get negative 1/2. 3 times negative 1 is negative 3, still is over 2. 5 times negative 1 is negative 5/2. Negative 7/2, so on and so forth. You can also say negative 0.5, negative 1.5, negative 2.5. Okay? In the next example, A is obvious, K is obvious, the H value is not quite as obvious. Because this has nothing with it, that means that the H value is 0. Because the A value is negative, it opens down. The vertex will be at 0, negative 3, and it is going to be a maximum because it opens down. This right here, the axis of symmetry will be x equals 0. The optimal value is y equals negative 3. And to find the step pattern, I'm just going to do 1 times negative 2, which is negative 2. 3 times negative 2 is negative 6. 5 times negative 2 is negative 10, so on and so forth. In the next example, we are given other pieces of information. First piece of information we're told is that it opens up, which means that the A has to be a positive value. We're also told the vertex, and the vertex is always going to be H and K. So that means that we know here that A is positive, H has to be negative 2, and K has to be 5. This is H, this is K, okay? So based on that, we know our axis of symmetry is x equals negative 2, and our optimal value is y equals 5. The last thing I need is the actual A value. So we know here the step pattern is always going to be 1A, 3A, 5A. So we know 1A is 7, 3A is 21, 5A is 35. Divide all of these through to solve for A. So I would divide by 1 here, divide by 3 here, divide by 5 here. Each one of these tells us that A is positive 7. So now that I know what A, H, and K are, I can go ahead and fill that into the equation for vertex form. So remember, the equation for vertex form is y equals A times x minus h squared plus K, right? So here I'm going to say y equals, instead of A, I'm going to replace it with 7. And I'm going to keep the x there. And it's x minus negative 2. So minus a negative becomes plus a positive squared, and then plus 5 right here. Go ahead and try the last example here, and then come back and see how you did. So here we know the axis of symmetry is 3, the optimal value is at negative 2, so it would be 3, negative 2 right here, which tells us that H is 3, K is negative 2. We know that the A value right here, that 1A is negative 4, 3A is negative 12, 5A is negative 20, which means that A would have to be negative 4. Go ahead and try the next example here. Press pause, come back and see how you did after you've done it. And then if you have any questions about it, write it in your notes so that I can answer your questions for you. Okay? So that means our equation would be y equals negative 4 times x minus 3 squared minus 2. And we know that this is going to open down because the A value is negative. Okay? Same, just a reminder, if you have any questions, just let me know. Okay? All right, so let's go ahead and apply this to graphing quadratic relations in vertex form. So we've got 3 different options on how to do this. We could either use a table of values, we could use transformations, or we could use the vertex combined with step patterns. So in our first example, we're asked to use a table of values. So here we want to graph out y equals negative bracket x minus 4 squared plus 5. So if you look here, it says to create a table of values for x and y. And if you can see here, it's already set up for us. And we have to make sure the vertex is in the middle of the table. So first thing I want to do is identify the vertex. We know the vertex would be a positive 4 followed by a positive 5 because the h value is positive 4, the k value is positive 5. So I'm going to put that in the middle of my table. Okay, then I'm going to just go up by 1s and down by 1s. Okay, the fact that this is a 5 here has nothing to do with the fact that this is a 5 here. It's just a coincidence, okay? Then I'm going to plug in my information into the equation. So y equals negative x minus 4 squared plus 5, okay? So every time I see an x, the first time right here, I'm going to replace it with a 2. So I'm going to say 2 minus 4 squared plus 5. I know that 2 minus 4 is negative 2 squared plus 5. Bring the negative in front. Don't forget that the negative stays in front right here. Square the -2, you get +4, but bring down this negative, you get -4. So I know that this would end up being +1. So we know right here, this is +1. Let's do the next one right here. So y equals -x minus 4 squared plus 5. But this time I'm going to replace this value here with a 3. So I'm going to say 3 minus 4 squared plus 5. And I know 3 minus 4 is -1. Copy everything else down exactly how I see it. -1 squared is +1. Bring down the negative in front. This negative, I get -1. So here I get -1 plus 5 is 4. So this is a 4. By putting this vertex in the middle, I know already that my graph will be a symmetrical graph, which means that my corresponding y values will also be symmetrical. So if this was a 4, then this will have to be a 4. If this was a 1, then this will have to be a 1. And then I can go ahead and do my graph. So my first point is at 2, 1. Then I've got 3, 4. Then I've got 4, 5. Then I've got 5, 4. And lastly, I've got 6, 1. Connect those dots right here. Write the equation. And then we're done. So let's take a look at our last example that we have here. So in our last example, we have, we're asked to use the vertex in the step pattern, and we want to graph out y equals -2 times x minus 7 squared plus 9. So the first thing that we need to do is determine the vertex in the step pattern, okay? So we know that the vertex is going to occur at 7, 9, okay? Now the step pattern, to be able to do that, we need to figure out what a is, and we know that a is -2. So 1a would be 1 times -2 or -2. The next one is 3a, which is going to be 3 times -2, which is -6. And then 5a would be 5 times -2, which is -10, so on and so forth, right? So we've determined the vertex and the step pattern, which is -2, -6, -10, so on and so forth. Done. Plot the vertex, okay? So we're going to plot the vertex at +7, +9, okay? Done. Determine the direction of opening. Since a is negative, our parabola is going to open down, okay? And then plot the points, all right? And it says here, over 1 and then up or down a, right? So this means that we're going to go over 1 and then up or down by 2. Over 1 again, and then up or down by 2a. 3a, which is down 6. And then 5a means we're going to go down 10. How do I know it's down? Because it's a negative. So let's go ahead and do that. So I'm going to go over 1. And then I'm going to go, again, I'm going to do these little squiggly so you can see what I'm talking about, but then I'm going to get rid of them. So I'm going to go over 1, and then I'm going to go down by 2. And this is where my next point is. And then from here, I'm going to go over 1 and then down by 6. 1, 2, 3, 4, 5, 6. Where did I get the 6 from? From this part of my step pattern. And then lastly, I'm going to go over 1 and down by 10. I think this should be enough points for me to see what's going on. So over 1 and then down by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's half of my parabola. Then it says draw the other half of the parabola in a symmetrical manner. So we know that this right here is my axis of symmetry. So that means that this is going to reflect over on this side. This is going to be 2 away from the axis of symmetry. This is going to be 3 away from the axis of symmetry. So as you can see here, everything here is symmetrical. Connect your dots with a nice even curve. And this is the graph, of this parabola. Okay? Again, you get to choose whichever method you prefer, as long as you choose a method that makes sense to you and you can communicate that method properly. All right, that's it for this video. Let me know if you have any questions, and I'll see you in class. See ya.